Okay, so on Friday we mostly just got stuff written down, and then we kind of had some distractions and stuff, and then we didn't get much done. But we will finish this stuff up today. Um, so what we were talking about, it kind of builds off of what we were doing on Thursday, where we were graphing the scatter plots and then trying to fit a equation to our scatter plots, pending if it was like a straight line, more like a curved one, like a parabola, or if it was the inverse variation ones where they were kind of going downhill. And then we kind of broke it into a little bit more specific stuff where we were talking about, okay, well, as our x value doubles, what happens to our y value? If it's doubling just like the x is, then it would just be like to the power of 1. If we double the x and then our y would be times 4, then it'd be to the power of 2 and kind of so on there. And then the same works with our inverse variation stuff. Okay, so we're going to use that to kind of go through this board example here. So we talked a little bit on Friday about this as well, but that board example, if I flip to it in the book here, is where there's like a construction worker walking here, and we talked about like what's a better board to walk on. Is like a thinner board or a thicker board better to walk on? A thicker board, right? And then what about like a skinny board or a wider board? A wider board. What about a long board versus a short board? A short one, right? So kind of depending on, different variables, we can have different sturdinesses of our board there. And that's kind of what we're going to map out here. But kind of the general point of that is it wouldn't just be one factor that's affecting that. It would be like multiple factors affecting it: the length, the thickness, and the width. Okay, so what we need to do is we need to come up with an equation for all three of those things. Okay, so we always keep one thing a constant, and then we change the other stuff. So here, for example 1, and this should be in your little packets, it says our max weight as a function of width, and we're supposed to determine how m varies with w. So m is our max weight, w is our width of the board, and then find our constant of variation k and use it to verify our relationship between the two. Okay, so first thing I would do there is I'd look at two numbers that are doubling. So like say I went from like 1 to 2. Wouldn't that be like times 2? Okay, so now I compare that with my y values for that. So what happens with my 9 to 18? What am I doing there? Times 2 as well, right? And I'm thinking there, okay, well, as my x value increases, what happens to my y value? It's also increasing, right? So what I'd be thinking when I go back here is this stuff up here, as my x goes up, my y went up, so that would go with these top three, and then it was just straight up doubling and doubling, right? So shouldn't our probably equation that fits with that y equal to kx? Yeah, yep. So that's what we're kind of going to be doing, and we still do the graphing and the scatter plot stuff just to make sure that it does that, but yeah, that's just kind of the general concept. So here I would go and I would graph these. So it looks like we're going up to 6 for our x values. So that would be across the bottom here. I'm going to just count by ones. And that W for our X stands for width. And we're in inches. And then up the side for all of these, we're always comparing these to the maximum weight that we can hold. So up the side will be our max weight, and that goes up to 53. Oh, I think there's 10 lines, so if we count by 5, we'll be a little bit over when we go to 53, but you want to count by 5s? 5s probably be easy. Okay, so we'll go 5, 10, 15, 20, and so on.
I counted by 9s, is that fine?
I don't care. 9 seems like an awkward number to count by, though.
That worked.
Yeah, whatever. Okay, and then that was our max weight in pounds. And then we'll just graph those out. So like 1, 9, 2, 18. Number 53 will go off our graph, but that's okay. Okay, and then looking at our scatter plot in general, what's it in general look like? it looks like a straight line, right? Which, if we go back to the 2-7 notes, remember our straight line ones where it was just like the y equals k to the power of x, which is the one that we kind of thought it would be, so that kind of verifies that a little bit for us. And then how do we find our k value? You may remember? Yeah, take a point and plug in. So like if I just pick one at the beginning there, so like 1, 9 and plug that in, so my equation that I'm gonna try out here, m for my y value is equal to k, and then w for my x value. That's my general equation. I'm going to check to see if it works. I'm going to try. I'm just going to do 1, 9 as my point that I try. So I'll put the 1 in for our width. And then the 9 in for our m for our max weight. And then really there, what is k times 1? Just k, right? So wouldn't our k be equal to 9 then? Yeah, and then what do we do with that k value? Plug her back in. So then we'll have like m is equal to 9 w. And then how do we see if that's valid? Plug in another point, right? And I would plug in a point that wasn't one that we checked here earlier because we kind of already checked it with the 218. So I would use one of these points a little bit further off here. Doesn't matter which one. Which one do you want to use? 436. Okay, so if we go, so we'll check it with 436. So we go m is equal to, I always just plug in like our x value there and then see what it kicks out. So it'd be 9, 4 for the w. And then what is 9 times 4? 36. So did that work out like we needed it to? Yeah, it did. So is that a good equation for us? Yep, absolutely. So you could either write it as m is equal to 9w. We're just going to do general equations here, though, so we're not going to worry about k values for now, because what we're going to do at the end is we're going to take all three of our equations and we're going to put them together as one equation. So I'm just going to do it as m is equal to k times w for now, because, like I said, we're going to combine all three equations together, and the k values will vary when we put all three together. Okay. Kind of making sense? A little review from that 2-7 stuff, basically? Okay, so now we have to do that with our other values here. So we also have the thickness of the board, and then we have the length of the board left to do this for. Okay, so same concept here. We got our thickness, max weight, so thickness is going across the bottom. And again, we're comparing all of these values to the max weight. So that would be like our y value. So thickness, inches again. That goes up to 6 as well, so we'll just count by ones again. And then up the side, this one we go up quite a bit, right? And that makes sense, because if you make your board 6 inches thick, isn't that a pretty solid board? Yeah, like I don't even know if the beams in my house are 6 inches thick, because that's pretty solid. They probably are. But that'll hold a lot of weight, right? So that's why that's going up a lot quicker. So if we have to go up to 288, if we divide it out here, 288 divided by our 10 spaces we've got, we get 28.8. Is that easy to count by? No, what should we probably go with? 30 would probably be the best bet. You could count by something else if you want to count by 28.8, Thurston, go for it, but
Oh my god. No.
I'm just harassing you.
Yeah, I know.
That's what I'm here for. Okay. So yeah, 30, 60, 90, 120, 150, 180, so on. And that was our max weight again in pounds. Like I said, this one's going to go up a lot quicker because, you know, a thicker board's going to be more substantial when we stand on it. Okay, so then when we're graphing what we didn't do is we didn't do our beginning thing to do our check here. So if I go from 1 to 2, that's doubling, right? What about 8 to 32? What's going on there? Times 4, right? So if that's times 4, looking back to our thing here, which one's probably going to be our best bet? Probably the second one where it's squared, right? So when we graph this, if it's going to be squared, what should our scatter plot kind of look like when we graph it? Should be straight or a curve? A curve, right? Because it should look more like a parabola when we graph it, and we can confirm that here. So 1, 8. Let's get her graphed up. do we think? Does that kind of confirm our thoughts that it's going to end up being a little bit curved? Yeah, so that helps us out because then we know it's probably going to be the one with the x value squared. So it would be like our m for our y values. So m is equal to k. But then this time for our x, we're going to do to the power of 2 because it matches our curved one. And again, if you're not, like if this thing doesn't make sense that we've been doing, you can always just look back at these. And then you remember how if it's the curved one, that was the x squared. You can also look at that. Okay, and then again, you just want to pick the first one there to find our k. Yeah. Okay, so if we do that, so we'll try 1, 8 in there. So if I put a 1 for the t, it's always nice when it's 1 because that makes easy math, right? Because what's 1 squared? 1. So then we got 8's equal to k times 1, and what's k times 1? K. So our k would just be equal to 8. And then what do we do with the k? Plug her back in, good. Getting the hang of this. So if we do that, now we're looking at the equation m's equal to 8 times our thickness squared. And then again, I wouldn't use this point here because we've kind of already done some checking with that when we did that times 4 stuff. So I would pick another point there. What's another one you want to try? 5, 200. Okay, so if I try or check it with 5, 200, the 5 will go in for the t, so it'd be m is equal to 8, and then put the 5 in there for the t to the power of 2. Making sure we're following our order of operations here. What do we do first? Parentheses and the squared part before we do multiply, right? So what is 5 squared? 25. And then we'll have 25 times 8, which is 200, which is awesome because isn't that what we were looking to compare to? Yeah, so did that work out for us? Absolutely. So again, you can either write it like that, or the better way to write this is just the general one because like I said, we're going to combine them all together. Just m is equal to the k and then t squared. So that's going to be the one that we're going to use when we combine them. Okay, one more here and then I'll show you how the combining works. Okay, so this one, now we're comparing the distance or like the length of our board to our max weight. So distance across the bottom, max weight up the side again. Distances, we're just counting by ones again. And this time our distance is in feet, which makes more sense than comparing it in inches, right? Because if you just make your board an inch longer, is that going to make much of a difference? No, but if we make it a foot longer, that's really going to give it to Bo, right? Okay, and then max weight will go up the side there. Looks like our biggest there's 212. So, I don't know, what do you want to count by? If we divide it out, it'd be 21.2. So if we count by 20s, we'd be okay. We'd just go off our graph a little bit, or we could go up. If you want to do 25, 25 is probably not a bad bet. So we count by 25s up the side. And that's our max weight. Again, in pounds. And like I said, those y values will always be the same when you compare these because you hold that constant. Okay, and then let's look at our numbers here. So if I go from 1 to 2 times 2, right? What happens when I go from 212 to 106? I'm dividing by 2, right? So if I'm dividing by 2, do I worry about doing like my top 2 there, or is it the bottom ones? The bottom ones, right? So if we go back here, all of these ones are our dividing ones because if we look at our x's, as our x goes up, our y goes down. Well, if we look here, as our x is going up, is our y going down? Yeah, so that makes sense. So we're going to use these bottom ones here, and then it was just straight up 2 and 2, right? So we're probably thinking it's going to lean towards that one there, y is equal to k over x. And then we'll graph that just to confirm that. And these are the ones where it's the nicest that we have this extra way of checking here, because you remember when we were doing the one on Thursday where we knew, okay, well, as our x gets bigger, our y gets smaller, so we were looking at these two, but then looking at that one and looking at that one, weren't those very similar to our setups? Yeah, where they were kind of both going downhill and curving down there, downhill and curving down there, and then we had to try out both of them to see which one was a better fit. In this case, because we did our extra work, we shouldn't have to try out both of them, because the one that we're looking at here is going to be, as our x is doubling, our y is dividing by 2. It should match up with this one here where it's just the regular x and not the power of 2. If we didn't have this extra strategy, we'd probably have to check both of those. Okay, but this will kind of narrow down our options. It should end up matching with that one there. Okay, so if we do that, then if we take that equation, so it would be m is equal to k over our regular d, right? We wouldn't probably have to check it with the squared because of what we kind of confirmed there. So then we'll try it out with what point you want to use to try it. 1, 2, 12, that's probably a good one to try. So our 1 would go in for our distance there. Max weight would go in for the, 212 would go in for our max weight. And then again, there it's kind of nice when we use 1, because what's k divided by 1? Just k, right? So it'd be 212 is equal to the k. And then same as before, take that k value, plug her back in. So m is equal to that 212 over d. And then we'll check that with another point. And again, I wouldn't use the 2106 because we know that'll work because we kind of confirmed that before. So I'd pick a different one. Which one did you say? 3 and 71, we can do that one. Okay, so if we put so if we check 371, and it doesn't matter which point you use to check, we're going to put that 3 in there for the d value. So m is equal to 212 divided by that 3. And if we do that out, 212 divided by 3, I get 70.6 repeating. So what do we think? Is 70.6 repeating?
Yeah.
Close to 71? Yeah, it would be, right? So does this seem like it's probably a good fit? Yeah, and again, those other two were spot on, that they were exactly the same, but it doesn't have to be. They can be just close, just like we were doing the other day. So yeah, the one that works there would be m is equal to 212 over d, or the general one of that would be m is equal to k over d. Okay. So now the thing that's a little bit new to us is now what they're going to want to do is they're going to want to combine all of those equations together to make one. So it says write all of the relationships from the previous examples as a single formula, and then do not find the constant of variation. So because each of our k values is different here, that's going to have kind of an effect on it. So like the k values we use aren't going to work. We just leave them as a general k, and we just leave that in our final equation. So what we're going to do is each of our equations there should have equaled m, right? And all of these were either direct variation or inverse variation, so they all had a k value in them. And then what we're going to do is we're just going to look back at each of our equations. So like that first equation we did, we got m's equal to k w. So if the w is on top like that, what do we call that? Is that direct or inverse? Direct, right? So what we do is we need to put the w in the same position when we do our equation here on top to make it direct. And then we'd look at our next equation there, which we got m is equal to k t squared. So what do we think with the t squared? On the top for direct again, right? Okay, and then if we look at our last equation here with our d, The inverse one, yep. So we put that one on the bottom because it's divide. And then that's it. You don't have to find any k values or anything like that. You just take all of your equations that you came up with and put them into those spots. Okay? Okay. So you got the rest of the time to work on that book page there, 125, 1 to 11.